This is an 8 about the fundamental theorem of calculus applications. So, fundamental theorem of calculus. It sounds important. It is important. So, before you have the fundamental theorem of calculus, you really have two areas of calculus. And maybe I'm going to use this other slide to just kind of sketch things, and I'm going to delete it. This is just for you to sit back, relax, and listen. So when we derivatives, so we'd have something like 3x squared plus 9x minus 3. We would take the derivative of this, and we'd say, okay, well, that's 6x plus 9. We can take the derivative, and then also if I had the, bless you, if I have the integral of 6x plus 9, I can take the antiderivative, and I know that I'll go to 3x squared plus 9x plus c. We could go forward, we can go backward. The fundamental theorem of calculus connects these two worlds. It says that if you go backwards from something that you already started with, you can get back to the original starting place. You can go forward and backwards. It's something that we kind of already informally know in our bodies, in our bones, and now we know that this...
Yeah, well, like, it's true. It's like, it's not like we're thinking, oh, now that we've gone forward, we obviously can't go back. Makes sense.
Right, you can go backwards.
Why is it plus 6?
Plus c. Plus c.
I don't think that's true. You can't always go backwards.
So you can go backwards as long as you have the initial condition. So if I say,
Okay, Rose, let's make this into...
we don't know what c was until I gave you, oh, we started at position -3. If you knew that you started at -3, you'd say, okay, well, I actually know what c is. It's minus 3 in this one case. All right, so far so good?
Yeah.
All right, so fundamental theorem of calculus. Another general way of saying that, and maybe I'll add this to our notes, but it's generally if I have something like, I don't know, my computer's just lagging so bad right now. If I have f of x, my function is equal to the integral between 0 and x of 3x squared plus 7x. And I say, well, what is f prime of x? When I take the derivative of f prime, or of f, then this integral goes away, and it just turns into 3x squared plus 7x. So when I take the derivative, it cancels out with the integral. Make sense? All right, they kind of cancel each other out. That's fundamental theorem of calculus. I just want to be able to apply it today. So we have our initial condition. If I don't give you the initial condition, you can't actually go backwards all the way. You're left with that constant of integration. And I'm telling you that the rate s prime of t is equal to all of this. All right, so I know the rate that the water is increasing, so I want to answer this question. How high will the water be after 5 days? Answering this question is correct application of the fundamental theorem of calculus. I can give you a few other questions that you might see that also use the fundamental theorem of calculus on the side. So, let's see if I can read these notes. Actually, I'm going to come back to that. I don't think it's really important for this lesson. So how high will the water be after 5 days? What are we going to do here? We're going to use start plus change equals n, so we can write that again. Start plus change. Who dis? Victorville, California.
SAO?
It is. Start plus change is equal to n. All right, so our start was what, girls?
10.
10. What is our change? Change. Careful.
Or antiderivative.
Antiderivative
From 0 to 5.
from 0 to 5 of this thing, right? Of s prime of t. dt. I don't know why my computer's just lagging so bad. I might need to restart it. But anyway, so how do we find this integral? Calculators. So, calculators at the ready.
I feel like we're going to have like a standoff. Yeah, like my weapon is ready.
So we first need to enter our function. So we need to have 2 sine of 0.03 our variable. And we need to add 1.5. And then we'll do our second quiz. So our second mode. So hopefully our mode should be in radians.
How do you see if it is?
If you click on mode just once, it should be in radians.
Okay.
if you're ever in degrees, as long as you leave it there and don't reset your calculator, even if you reset your calculator, it'll defaultly go back to radians. All right, so integral. Tell us what to do.
So math.
Math.
9.
9.
Vars.
Vars.
Over.
Right.
Enter.
Enter. Okay. Y1.
Comma. X.
X, comma.
Comma 0, comma 5.
Comma 5. All right.
I got it.
8.24. 8.249.
I got 5.
So this is going to be 10 plus 8.249.
Wait, I got 50.
So that's going to equal 18.249.
Oh.
So if you're looking at our little picture here,
Oh, that's why.
you come up to right about here. So you would go, your change here is 8.249, 8.249, and your final position would give you to 18.249. Does it feel like we've already done this before?
Yes.
That's awesome, because we kind of already have. All right, so here's another type of question that I can ask. I'm going to write it underneath here because I think we have enough room. You should have 2 lines to do this question. All right, so my question now is, how high will the water be after T days?
I'm sorry. Can you show what you did on the cylinder thing? I missed that.
I just said that it goes up to 8.249, or it goes up 8.249, so your end,
Oh, you just drew where. Oh, okay.
Yeah.
Never mind. Thank you.
and I guess if I want to re-highlight this, it's now up to here.
Okay.
So, a slightly harder question. How high will the water be after T days? So instead of 5 days, it's T days. What are we going to do?
Plug and chug.
I mean, almost.
We need to find an equation.
Yeah, we need to find an equation. So again, it's start plus change equals end. So it's going to be 10 plus what?
Plus the integral of 0 to t.
From 0 to t, perfect.
And then s prime t.
S prime of t. And what is this going to be equal to? This turns into,
So it'll be 10 in front of the S? Or,
so, and this is kind of, I shouldn't really ask us what this should be, but when I take the integral of
st.
f of s prime of t, it gives you s of t as long as you include the initial condition. So this turns into s of t.
Plus 10?
S of t includes the 10 because 10 is part of the initial condition. Without the initial condition, you can't actually find the height at any point.
answer?
That's what we're looking for. Yeah, that's our answer. And that's kind of the key part of today. As long as you have the initial condition, you add the integral of the derivative. The integral and the derivative cancel out with the initial condition to give you your
And that's always the case. Like,
That's always the case as long as you have the initial condition. Sometimes the initial condition will be hard to find.
So as long as you have the initial condition, then the derivative and integral cancel out? Or they like combine to make one?
They combine to give you your original height function.
Okay.
And just if you want to add this, you can say that this thing right here was a rate. And this is just the water height. That's all we have for the notes. Super short today.